Good morning, ladies and gentlemen. My name is Saad Al-Mashari. I'm a Premier Field Engineer out of the UK. I know it doesn't sound like I'm from the UK, but it's a long story. Today's session is going to be a deep dive into ConfigMan 2012 database replication. We're going to look at exactly how database replication works at what you hopefully feel is a 400 level. So today's session covers the new replication model. We'll look at RCM, DRS, and SEDO. If you don't know what RCM, DRS, and SEDO are, hopefully by the end of the session, you will know. And we'll look at troubleshooting DRS. We'll look at the SQL Service Broker and how you can actually look at messages in queue. Think of it as, although someone will be upset with me, in a CM07 model, SQL Server Broker is now like our inbox. I'm sure that's going to annoy someone somewhere, but that's the closest analogy I can think of. And last but not least, thank you all for attending. I know it is Friday, and there are other things that you could be doing in Vegas besides coming to this session. Quite a few other things. I just wanted to give a shout out to a few folks. I don't feel that we ever do anything in isolation, and these folks help me out. John and Will, a lot of this content is their content, and I've customized it and made it a little bit prettier. And last but not least, DC Tardy, who helped review the session, put the final bits and pieces on it. While we're talking about DC, how many people attended his infrastructure troubleshooting session? Hands up. So quite a few people. We'll talk about DRS a little bit more than he talked about in his session because he was talking about the entire infrastructure troubleshooting. We'll start with concepts and terminology. This is just to level set the audience so that all of you are aware of the various terms and technologies, so we're not diving too deep into stuff early on and then you're like, well, what's that? We'll then talk about the architecture and internals of DRS, and that'll be full of diagrams. And then we'll talk about DRS troubleshooting, and we'll dive deep. We'll open up the SQL Server console. I'll show you how you can look at backlogs, how you can look at error messages. Hopefully we'll break and then fix DRS if my demos work. And last but not least, we'll talk about SEDO. And I'm intentionally not explaining what SEDO is an acronym for because that's a surprise at the end. So, concepts in administration or terminology. So, first thing, SQL replication in Config Manager 2012 has nothing to do with transactional replication. If you've been sort of living in a cave between Beta 1 and RTM, transactional replication is gone. No longer there. There are some remnants, and we'll look at a little bit of the remnants that are still there from transactional replication. They don't really matter anymore. The data replication service is the core method of data replication. Okay. But we still have content replication done using our senders, and we still use it a little bit for database replication, and I'll explain how. Throughout the session, I'm going to refer to stored procedures, or SPROCs. Stored procedures are just a SQL concept. It's a set of reusable code stuck in there. Think of it like a SQL script stuck into the SQL database. That's heavily used in DRS. We'll talk about SSB, or the SQL Server Service Broker feature, and what that is from both a SQL point of view at a high level, and then we'll dive deeper to provide more detail. And then we'll talk about change tracking and what that is, so that you can at least explain it to your DBAs if they ask, because there's a couple of SQL features that happily have the similar name, which makes it very fun when you're talking to a DBA, or other SQL engineers, as I do. From a ConfigMan point of view, RCM is our topmost component. Replication, configuration, management, or monitoring, depending on which log file you look at. A replication pattern is a set of rules about what will replicate. So take hardware inventory is a good example. Hardware inventory sliced up into multiple replication patterns. So the tables themselves are split into multiple replication patterns. Alert data for malware is a separate replication pattern. We sliced up replication so that we could have different schedules of replication and different chunks of data that we might move together. A replication group is similar in concept to that. Sorry, I'm suffering the after effects of last night's party. Flip that. A replication pattern is global site or global proxy data. It's a set of data, again, but it's a set of what we replicate. A replication group are the tables grouped together. And last but not least, a replication link. And they nest, as that little diagram shows you, one or the other. Replication link, think of it in AD. So if you're familiar with AD replication, you know, it's been around for 10 years or so, or 12 years now. A replication link is like your connection object between two DCs. Yeah. Backlog, I was told to put this in here. A backlog in DRS, or in database replication, is defined as when you're unable to write data into the SQL Server DB once it's received by the receiving site, not when it's queued on the sending site. Of course, I then asked, well, what do you call that? And they said, well, it's also a backlog, but we don't call it that. And I was like, all right. So it's in there. New replication model, you've probably seen this before, but it's just, again, there to level set everyone. Global data replicates in both directions. It's anything that the admin creates. So you create an object, you create a configuration, that's global data. Site data replicates up. That's stuff that clients are generating, right? The CAS is going to be clientless, obviously. But the data coming from clients flows up. And then last but not least, we have the global data subset or global proxy in the database. And that replicates between our secondary sites. For what it's worth, I will use the same icons throughout the presentation. So when you see that nebulous looking thing, it's the closest thing I could find to a Metro icon for the CAS and our primaries and secondaries. So this diagram has an intentional flaw, and I just want to see if anyone can spot it. It's a CM07 flaw. See if anyone can spot it. There's an asterisk in there. So the client generates a MIF file, and there's your asterisk, and copies it to the MP. The MP copies that MIF file up to the site server for the site. It inserts it into its database, takes the same file, passes it up using the sender to the parent primary site, which processes it again, and then the central site processes it yet another time. In CM12, the client generates a MIF file, copies it to the MP. The MP then does the same thing, passes it to the site server. The site server processes it, again, similar to CM07. And then DRS replicates the change out. And that's done at the SQL level. We don't reprocess the data. There's no more moving it back into a MIF file just to send it out again. And the CAS receives that SQL data. So my question is, can anyone spot the mistake there? It's a geeky question. What does the client generate when it sends hardware inventory? It does, yes. So, but I just left it in there as a MIF file because I like geeky jokes and it's Friday. The next slides, this is a warning slide. The next few slides relate to SQL technologies. They are not specific to ConfigMan, but I think it's important to understand the underlying technology so you can understand how config-man uses it so that you can troubleshoot it in your environments. Don't modify the configurations. That would be bad. So the first feature, and it's the most important one, is change tracking. Now, you're going to go to your DBA, and you're going to say, hey, we're using change tracking. And he's going to say, great. So you're capturing the data. And you're going to say, no, we're just tracking the changes. Why? Because there's a feature that SQL calls change data capture. They're very similar, but we use change tracking. Change tracking just provides us with a list of rows that have changed. And then it's up to the application to go back in, read what's changed, and then process it, insert it somewhere else, do something with that data. Change data capture, on the other hand, actually captures the change data, right? So again, to go back to AD, in AD, we write a change value for replication. And then when we actually go out and replicate it, we get the real data and replicate it. But we know what's changed by using the USN changed value to track changes. So just bear that in mind if you ever have a conversation with a DBA at the water cooler about config-man. It's set at the database and the table level. You'll see in my example here, we're using the AdventureWorks database that has it set to 2 days. Yeah. You might be tempted to open up the database properties on your config-man 2012 environment, take a look at it, and say, oh, hey, it's 5 days. Let me change that to 30. Don't. It would be bad. And we'll talk about why it's bad, why it's set to 5, what happens if you don't have replication after 5 days. SQL Service Broker. It's an asynchronous queue-based service, which is developer talk for a system that just allows them to drop messages and fire and forget, basically. They tell the SQL server, get it from point A to point B, and don't bother me again. It's similar conceptually, again, to MSMQ or MSDTC, or if you came from a development background, it's similar to BizTalk at a very conceptual level. BizTalk's obviously much more complex. We do have the word guaranteed. When I was talking to the developers, they said, you have to put the word guaranteed in there. And I was like, yeah, but can I put something else? Can I put something similar to guaranteed? No. It's guaranteed delivery. Now, what that really means, that means something completely different to a developer and to an IT pro. Guaranteed to them just means, yeah, I don't have to worry about it. I just write my code and say, get it for me out there. For an IT pro, there are still many ways for things to fail. If DNS happens to go haywire, if SQL Server stops running, there's no magic guarantee there. And last but not least, it allows elasticity. It allows us to spin up additional worker stored procedures or activation stored procedures to be able to do work off of the queues that we have. That's what it sort of looks like. I'm not going to go into this too much. It's a generic SQL view of that data. Suffice to say that we have a service with a conversation that has queues. So the initiator, or config-man in this case, drops it into a service. That service is represented by one or more queues. So there's basically a contract like you'd have with FedEx saying, I want it there in 48 hours or 5 minutes or what have you. Obviously, you wouldn't tell FedEx you wanted it there in 5 minutes. That drops it into a queue, and then the route. And the route is the low-level TCP connection. That really gets implemented in config-man as an HTTPS or HTTP over TLS connection with encryption and so on. So, replication patterns. We have global data. This is what used to flow up in CM07. It now flows in both directions, which I'm sure you've heard a lot about. All CASs and the CAS and all primaries have the same data. Site data replicates up. The CAS aggregates the data for us. And then we have global proxy, which is our last subset, which is what secondary sites get. The main piece of information in there is the site control file. Because we eliminated sender replication for the site control file, the data that was in the site control file, there's no longer a site control file, is in SQL and therefore has to be replicated. And we leverage SQL Server 2008 R2 Express, which gives us a 10 gig limit, which hopefully none of you should ever hit because it's quite massive for the data in global proxy. If you're worried about it, I do have a stored procedure up here that I'll show you that actually gives you the ability for your running sites to determine how big global data is, how big site data is, and how big global proxy data is. If you need to figure out how often something replicates, so let's say you look at a view and you say, well, my boss has told me to tell him how quickly that data is going to get around my hierarchy, or how long it will take for a change from one primary site to reach another primary site. What you can do is look at the views. The views will tell you what table they use, and you can go into this view and determine what pattern that falls into. It's a combination of replication data and article data. ID will be the key field in there, and sync interval tells us how often we replicate that. So again, this is just to give you an idea, right? So I've talked about these concepts. Site data, that's what you can think of as site data. Global data, you've seen that as well. Provider access. So it's a 400-level session. Figured we'd talk about the provider. SMS_replication group is a new WMI class that supports replication. There's one instance per replication group, and it lets you determine the status of the replication group. Right? So this is what the console uses to show us some of the data about replication. So if you're doing any sort of custom monitoring in your environment, this would be a good class to use. And we'll talk about initializing data and reinitializing data a little later on. There's a method in there. To figure out the tables, you can use select star from V article data. There's a slight typo in the slide. That should be replication ID with one word, not two words. So let's say you take a hardware inventory group. We'll look at this in the demo in a second to sort of show you what this looks like. And the article data will tell you the individual tables. All right? And this is what we found from V replication data. Here's the stored proc that will tell you the size of the replication groups. This is important operationally. So let's say you have a reinit occur. You have a site go down for 7 days, 14 days, whatever, and data needs to be re-replicated. But you've put that site on a really slow WAN link, or you really throttled its sender. And you've got 10 gig of data at that primary. How long is it going to take to replicate that 10 gig of data up? Well, to take a step back, how did we figure out it was 10 gig? Anyway, so you can do the calculation once you know it's 10 gig, but this will actually tell you how big it is. So let's go and take a look at replication. So the first thing we want to do is we want to do a select star from V replication data. Fire that off. And you can see here we've got various pieces of data in there. We've got the global patterns. We've got our site patterns. And we've got our global proxy patterns. And you can see there, it's basically just site data and the how to replicate. Sync interval is the number of minutes at which we refresh this data. One thing to keep in mind, if we haven't covered it all, if you haven't heard already, is there's no way to control DRS replication. DRS will replicate every 5 minutes, whether you like it or not. There's no throttling on that connection. That doesn't apply to initialization and reinitialization. We'll talk about that a little later on because that uses the sender. Is push, this came up in the lab yesterday, is push is a holdover from transact replication. Everything fires on a schedule now. It was more important for transactional replication to choose whether or not it was push or pull from a SQL Server subscription point of view. Transport type, another not so interesting one because it's all DRS. It was more interesting in beta 1 because you had transact replication in there. It's not in there anymore. It's all DRS. So let's pick, I normally pick on hardware inventory, and that was the point of the slide for the demo. Hardware inventory has lots and lots of tables, or lots and lots of tables and lots of replication groups. The reason that we've sliced it up is so that when you start adding any tables due to customizing the SMS def.moff or other things, that will then need to be extended via DRS, and that kicks in there. Also, there are so many tables that we wanted to slice it up. We didn't want to have a massive amount of replication kick off every 5 minutes if it wasn't needed. Yeah? So let's look at endpoint protection malware threat data. So what I'll do is spin up another one. We'll take a look at the article data, where replication ID equals 7. And those are all our malware threat data tables. So article name in that case is the table name being used. And again, you wouldn't necessarily want to go from table out. You'd go from view, and from the view, you determine what table it's using. Because we don't publish the schema for the database. We do publish the schema for the views. So while we're in here, we will look at programmability, stored procedures, and there you go, diag get space. And we'll execute the stored proc. Takes a bit of time because it is summing up the size of all the tables. We'll let that run. And you can see here, I can go in there and I can see database level stuff, which to be honest isn't that interesting because you can do that with other SQL tools. What is interesting is, where did it go? There you go. Replication pattern, global proxy, and site data. So now we know that if I were to lose my primary site and I needed to re-replicate that, obviously I don't have that many clients because that's why that number's so small, but it would take me 17 meg to reinitialize that replication. But I'd also take 600 meg from the CAS down to the primary during that reinit as well. So I think that one will be a useful stored proc to use in large environments that may have downtime on their primaries. So let's jump into some diagrams. RCM is our command and control. It's the brains of the operation. RCM is a thread of SMS exec, and bear that in mind. If SMS exec stops running for whatever reason, replication will not occur. Okay? That's an important thing to remember because it means that if, for example, obviously monitoring SMS exec is important anyway, but a lot of people, when they started looking at RC2, they started looking at RTM, they said, well, why is my data not up to date? And they're looking at SQL, they're trying to troubleshoot everything like that. They forgot to do the basic stuff and just see if SMS exec is running. SQL Service Broker is our transmission. It's the legs of the operation. And then, for the old timers, the sender still lives. We use the sender as part of a bulk copy procedure, or BCP, to move data during initialization reinit. There is a 5-day limit on DRS changes. So, we only have change tracking turned on for 5 days. If you were to increase that, A, you'd be unsupported, but B, your database would continue to grow and become very, very large. The reason for that is every single edit on every single table, insert, upsert, update, delete, is tracked. And it goes into the tracking table. So, you make that 30 days. Well, now you have to retain 30 days worth of changes. Okay? So some TAP customers experimented with changing this because they said, hey, we'll just flick it up to 30 and then we can have a 7-day, 14-day worth of outages. And then their database filled up and they were like, okay, no, we'll set it back to 5 and we'll be good. So that's one of the reasons why is it 5 days. Why is it 5 days? Because that looks a little weird. It's to handle the long weekend. So we thought the most common failure reason that a site wouldn't be turned back on is the long weekend. So someone goes out, the site breaks at the beginning of a long weekend, no one's looking at it, they come back the weekend after, 4 days later, and they say, wait, oh, I'm reinitting everything, my site's on hold, I can't do anything. With the 5-day limit, that means that they wouldn't hit that, replication would just continue. So that's one of the reasons why the 5-day limit was chosen, because we figured that would be the most common failure scenario. So, high level, and there's a legend down there. We've got RCM that's sitting as an SMS exec thread. On our initial replication, or reinitialization, we use BCP, which is a SQL Server feature, to extract table data, right? And the reason I say extract table data is you could always pull data out of config-man 07 when you did a site attachment or you dropped a SHA file. When you did that, it would actually export the data in the format of every single thread and then drop that out, so it had to be reprocessed. BCP is completely different. What BCP does is it goes into SQL and says, give me the table data. And it extracts the table data, and it sends the table data in exact format. And SQL can just take that data and shove it straight into the table without worrying about anything, assuming that the formatting is correct, obviously. You can't do it cross tables because that would be bad. We then have SMS exec sender thread, typical stuff, and then sifs/SMB to get it out to our destination. Nothing new there. For ongoing replication, change tracking is going on, capturing all the changes for us. That then gets handed over to our DRS store procedures. So everything in DRS occurs as a sproc. Okay? We do also use some SQL CLR if you want to be pedantic. SQL Service Broker then kicks in, and then that uses XML messaging over HTTPS to replicate the data at a low level. The sender piece is controlled, right? It's sender. The service broker is not. It gets dropped into a message every 5 minutes. You saw all the schedules. They're nothing longer than 5 minutes, and it will replicate. So that means if you were to do something crazy like deploy a piece of software disk that said delete all inventory, reset inventory on all the clients, and then kick off a hardware inventory across all my clients and a software inventory while we're at it, that would cause a lot of data to replicate within 5 minutes from your primary to your CAS. I wouldn't suggest you do that, but it's something to keep in mind because it's a change from the way that CM07 worked. CM07, we had control over that because everything happened via the senders. And no, there's no way to mess around with the schedule. All right. RCM is configure and monitor. It sets up replication. It also does a nice job of keeping track of replication. And this has gotten better and better. It will actually look at your config and start getting very upset when your config isn't set correctly. We'll actually look at my test environment where I've made a couple of mistakes, and it's actually upset at me because it's like, no, you haven't configured it correctly. So it's constantly monitoring things. So we're going to try and break replication. So let's say that you've handed this over to your SQL DBA. Your SQL DBA, for some reason, has had a bad day, and he's grumpy. And he goes into the queues, and he says, oh, hey, this is an interesting queue. Yeah, I don't think we need it. Yeah. I don't know why it's there, but I don't think we need it. And so what we'll see, and that's my CAS. So we'll go into the CAS. And if I've set up my demo environment correctly, he says, I should have SMS trace on C drive. And I can show you RCM control doing its bit. Oh, that's fine. We've got the CD there. No, because it's on the CD drive. There we go, RCM control. Open that bad boy up, and see, it's already annoyed with me. And so you can see there that it's going on. Yeah. So it ran that earlier. Let me show you a little bit higher up. So it's constantly sat there monitoring, running configuration, ensure that the SQL Server queues are enabled. This actually annoyed one of our engineers because he was running the labs for ConfigMan internally, and his demo for breaking DRS was to actually pause the queues. And then they introduced a fix where RCM actually just turns it back on. So it made it really hard for him to run his labs. And there we can see DRS picking up, and it says, hey, your queue's disabled. And it's gone out, and it's fixed it. And you can see it's very, very polite, and it's telling us that it's now turning it on. So now if we go back into SQL, you'll see that in SQL, if I hit F5 instead of F4, you'll see that it will actually now have reset automatically. So our SQL DBA has been thwarted in his attempt to make our lives more difficult. Now, the other thing that's worth looking at is while we're in here, we'll look at replication. And you'll see here that my link is degraded. If I go into monitoring, you'll see on this side it says active. And if I go into parent site, you look at the configuration there. Okay? So I've got some issues replicating back up, but replicating down is fine. But you'll see that we're actually monitoring a whole lot of configurations. Yeah, so we're checking the machine cert, we're checking the SQL Server certs, we're doing all this stuff in the background and monitoring it, and we're actually surfacing it in the console rather than in a helpful status message as we're all used to. So it's actually in the console. Site initialization. Site initialization is important because that's the very first thing that happens when you install a site. So we've got our new primary down at the bottom. Setup starts. It'll ask the CAS for what's called the site number. Of course, you're immediately asking, what is a site number? A site number is an internal mechanism for database replication that marks out a site. The site number, if you have a CAS that's running on SQL Server Enterprise Edition, so you've got more than 50,000 clients, and you're installing Enterprise Edition on your CAS, the CAS will actually use site numbers to do database partitioning. So one of the things that we require now is if you have more than 50,000 clients at your CAS, you should be running Enterprise Edition SQL so that you can get some performance benefits out of partitioning the database. And the CAS uses that site number to do that partitioning. And it's a way of chunking up the data in the database as well. Setup then finishes. It's got its identity now. It's happy. And then it talks out to the CAS again and it says, give me the replication configuration data replication group. Right? And that's just handshaking. That's how we're going to replicate together. The CAS then receives that request and it BCPs out the data and sends it via the sender back to the primary. So we extract that data, drop it onto the sender, and send it back down. The primary site then processes that and says, great, now we know how to talk. Give me the rest of the replication groups. The CAS takes that data, creates a nice big BCP package, and sends it back down to the CAS. Now, the stuff on the left-hand side, yeah, the blue boxes, if you have an outage of more than 5 days, that will occur automatically by ConfigMan. It will say, hey, I'm out of date. I'm not going to trust you anymore. I'm going to have to reset things. You immediately say, well, why does it do that? Well, what happens, let's say you have an outage for a week. What happens on the 6th and 7th days? You lose the changes from the 1st and the 2nd days. They're gone. And so there's no way when that site comes back up that we can give that configuration. Well, maybe one of those configurations was to create an object or some other database consistency thing. And again, from an AD point of view, the way to think about this is what happens when you bring a domain controller back after the Tombstone lifecycle timeout? No one's going to trust it. Same thing here. What we do in this case is we automatically reinit, and we use the senders to control that bandwidth. Because again, site data can be very large. Global data will be generally smaller unless you have lots and lots of objects. And then the primary site receives that and inserts it into its database. It's happy, and then it can use site-to-site replication using, not site-to-site, database replication between the two sites, as we discussed, using Service Broker. So just to talk about this briefly again and visualize it, the provider executes a query that modifies a data table. Something happens, right? You've created a collection. SQL Server writes that into the change tracking table for us. It captures that change. It could also be an insert of hardware inventory that would also cause that. On DRS sync, so RCM kicks in. It fires off a DRS sync. Those changes, we go back out to the source data table. We grab those changes. We wrap them up into an XML message. We hand the message over to SQL Service Broker and say, please get it to this location for us, or these locations, if you have a large hierarchy. SQL Server does its job, gets it over to the other location. RCM on the receiving side is sat there monitoring and says, hey, there's work to be done. There's stuff in the queue. And it kicks off an activation stored procedure in SQL saying, go do some work. Right? If you're familiar with troubleshooting in CMO7, think of this like monitoring the file system. and it picks up something on the file system, and it says, all right, work to do. That's similar. The activation stored procedures kicked in. It processes the data, unpacks the XML, says, oh, okay, I need to insert that into that table. And it goes out, and it inserts it into the receiving site's table. So that's DRS message replication. Maintenance modes, this is largely in there for reference. Maintenance modes are when we're doing a reinit, or when we're first setting up boxes. Okay? So when a site's in maintenance mode, it's when data is not initialized. So during a reinit or during initial setup. Right? We don't want the other components in SMS exec going off and doing stuff. We want to keep them quiet and not doing anything until we come out of maintenance mode. So you'll see that in the console if you ever have reinit going on or you've just set up a new primary. These are what the maintenance modes mean. So the CAS, while a primary is attaching, is in replication maintenance mode. Yeah? The site is usable, but reporting data from that new primary may be unavailable, or the reinitialized primary may be unavailable. The primary site attaching to the CAS, that's going to be in site maintenance mode. Nothing is going on, right? Because it's got nothing. And there's no point in doing anything because it's just going to get overridden when the CAS inserts global data. Speaking of data being overwritten, one other thing to keep in mind about replication is another example from the TAP. The TAP customer in this case had a CAS and a single primary. And this was their lab environment. And someone had said they'd run out of disk space in their lab environment. And they lost their CAS. And they said, oh, OK, we'll get more disks. Of course, it took them at least a week to get the disks, let alone stick them in and reconfigure everything. So the CAS was unavailable. Well, the project team said, well, we can't stop. So what did they do? They started working on the primary. And they made changes on the primary. And they invested time and emotions into the primary. And the CAS came back up, and it said, let's talk to the primary. Oh, wait, I haven't talked to it in 7, 8 days. Oh, that's all right. I'll reinit. And the reinit said, guess who wins? Me or the primary? I win. And the global data overwrit all their changes. And they were quite annoyed. So, lesson is don't use the primary as a substitute when you lose the CAS, unless you're sure that you're going to get everything back within 5 days. So, let's talk about DRS troubleshooting. RLA should be your first stop, the replication link analyzer that's in console. And I'm sure all of you are going to say, well, no, I'm not going to do that. I'm not going to go into the console and run a troubleshooter. Come on. The reason why you should use it is, A, your operators will always have something predictable to use. You will know that they've run a certain set of checks. You're not reliant on them running through a manual checklist. The other reason is it can do some fairly aggressive things. Stuff that you wouldn't necessarily be able to do, like say, the replication is inconsistent, I'm going to re-replicate everything for you. You should then go pop into the RCM log. Maybe our SQL DBA has had a really, really bad night and has decided that not only is he going to disable the queues, but he's also going to remove writes from config manager. So RCM says, queues aren't turned on. I'll fix that. And then it gets access denied. At that point, you should really have a discussion with the DBA as manager. For transmission layer errors, right? SQL Service Broker to SQL Service Broker. Sometimes looking in the SSB queue is the easiest way to figure out what's going on. So in my demo yesterday, in the lab that we ran yesterday, we get you to break replication by changing the DNS entry with a host file. So we break replication by basically cheating and just saying, yeah, you replicate on this non-existing IP address. What you'll see is that in the SQL Service Broker queue, it will actually tell you DNS hostname not found, which immediately tells you what the problem is. To be fair, RLA did determine that there was some kind of network or firewall configuration preventing communication, but the SSB queue does tell you exactly the Win32 error code that you get. So if you like Win32 error codes, take a look at the SSB queue. All right? The main logging view is vlogs. Vlogs is our DRS log file. You might say, well, why don't we have a log file for that? The reason we don't have a log file is because getting a SQL Server stored proc to write out to a file, not a very secure way of doing logging. So instead, we log into the database, and that's accessible to you via vlogs. And we'll show you how to look at that in a second. We also have detailed message tracking that can be turned on. As you can see, you will be tracking every single message. So be careful with that. DRS logging. Yeah, I'd recommend that you limit that in a production environment. Don't select everything. You may compound an already bad problem. And the other thing is make sure that you order by log time, descending. You really don't want to be trawling data from 10 days ago. Grab the latest data and look at that. This is how you turn on detailed logging in the registry, and you'll see it's under Replication Configuration Monitor. So, other DRS troubleshooting processes. Make sure you have firewall port exceptions enabled in the Windows firewall. If you have that turned on your servers, we recommend that you do have the Windows firewall turned on your servers. HMAN. Remember HMAN? HMAN keeps an eye on this. HMAN will look at those configurations and make sure that they are correct. HMAN will also keep an eye on the keys for us. So when we do a setup, we actually use certificate authentication for SSB so that SSB can authenticate between the two. Again, you'll see HMAN getting upset if the DBA goes in and starts deleting certificates. And if the DBA is deleting certificates, you should probably start talking to security. Our DBA is turning out to be very evil. SPDIAG DRS gives us this output. You probably want it in this text view as sexy as that looks. You want that text output because if you have it in the view output, it gets all scrunched. And we'll take a look at what that looks like in a second. In there, you'll see site statuses. I've put the decimal to clear text translation for you in the slide deck. You also see in there that we have the replication group initialization status, DRS queues with their state. Another way of seeing that the SQL DBA has turned those queues off. The queue lengths, right? Ideally, you should have 0 and 0 there. Otherwise, you've got a backlog. A backlog in outgoing means that you've got some transmit problem. A backlog in incoming means that you can't insert the data into SQL fast enough. That's worse, because that would require money to fix in most cases. And that would be hard. Replication group status is the status of all the various replication groups with the links between the sites, so you can determine what's going on between those two sites. And again, we only use DRS now for transport type. That's how you can view the SSB queues. Take a look at that. And that's the actual system table with the transmission queues. This is the default query created when you run a right-click and view queues on. I'll show you that in a second. So, how to view the queues? Well, we go into SQL, and we right-click on queues, and we say, show us the transmission queue. Now, the transmission queue is kind of outside of these queues. These are the queues for the application. The transmission queue is the internal queue for SQL Service Broker. And luckily, we have nothing in there. If I go into PR1, and we go into Service Broker, which is my primary site, and queues, show me the transmission queue. This is on the same instance. You can see here that I actually have 2 backlog messages. And you can see that they're actually, when were they sent out? They were in-queued about an hour ago, which is, or sorry, actually a few seconds ago. So they've disappeared. Sorry, the clocks are British summertime and UTC. So notice what happened to me there was those times are actually in UTC/GMT. So keep that in mind. Otherwise, you'll do what I just did. Procedures for troubleshooting DRS. The very first thing, no doubt about it, is run RLA. Next, run spdiag DRS. That was that stored procedure we looked at. Check those data points. Then jump into the transmission queue. If your outgoing messages are stuck, that can sometimes help you determine why. Make sure they're active. Yes, RCM tries to keep them running, but again, someone may have just come off the back of an audit on their SQL config and decided that you don't need DBO rights to the SQL Server database for the computer account. Then do some diving of vlogs. Take a look at the RCM replication link status. Usually spdiag DRS will give you enough information at that point, but you can dive deep into that if you want. So let's take a look at a demo of that. So I'll go in, run a new query, and spdiag DRS. And that will run. This is the table view, or the grid view, and you can see it's very useful and readable. And there we have the text output, which if I hide this and bring that up, there we go. You can actually see the whole config there, and you can see that we have no messages in queue. How shall I break things? Choices, choices, choices. I'm just going to turn off SQL. SQL's turning itself off, and obviously my console there is going to go and get very upset. I'm going to go into administration, and I don't know. Let's take this policy, make a change. And now we'll just wait for DRS to kick in. So RCM will eventually kick in and do its cycle. So hopefully, was I quick enough? Let's see. Hopefully I caught that DRS sync. And if I have, then what we'll be able to see is backlogging on our central site. Yes, I know that it's not available. DRS. Yes, 4 messages in the outgoing queue, right there. And now, if I go into databases, my config manager database queues, show the transmission queue. So connection attempt failed. Yeah, and you can go in and, in fact, we might be lucky enough. Those are probably SQL errors because they're not underlying Windows errors, but unfortunately, I don't have ERR in here. Yay. That's good. The port's closed because there's no service listening, and it's actively refusing it. So now we've got an idea of what's going on and why that's occurring, and we've got the queue in there. So this has now, oops, not on PR1, on the CAS. Once RCM gets done with its little activity, it'll flip over to degraded. After about 25 minutes, it'll flip over to error. Right? So we go to degraded and then error. If I run RLA, RLA will kick in. One thing to keep in mind with RLA is don't do what I sometimes do and run it from a Win7 client where you don't have admin rights and then wonder why RLA gets upset at you. Make sure that you run it with admin rights, and it has to have admin rights on your entire hierarchy, or at least the 2 boxes that you're trying to test the replication for. And RLA will go out and do things. Now, if you tried RLA in RC2 or RC1 and you're like, it didn't do much, that was something that's been fixed in RTM. And you can see here is it's saying that there's network connectivity issues between those 2 boxes, which is fine. We've turned things off, which is what we expected because we did something that RLA won't be able to fix intentionally. And now we can go back in there. You can fire off that stored proc again. You can see we're getting a nice little transmission queue backlog. Sorry, it's not a backlog because it's on the sending site. The other thing that I wanted to look at while we're in here is let's do a select star, and I'm going to do star because I know there's not that many things in there. From that, order by bless you. From come back to that in a little second because I don't think it's quite picked up yet that we've completely busted replication. But that's fair enough. In there you'd basically see, in fact, let me see if I can see any older issues. I was hoping that I would have some other failures. That's fine. Manually reinitializing a replication group. You can go out and you can call a method and reinitialize the data and cause that data. Don't use it on a day-to-day basis to make things happen faster or something like that. I don't know. It's in there as a troubleshooting process. RLA will do that for you. I just wanted to include it there for complete coverage. And again, think of it like dropping a SHA file in CM07. Yep, that's in PowerShell, that little commandlet. You can use whatever you want, whether it's VB script or you can write a C++ app if you really are into that sort of thing. For the reinit, and I'll just show you what vlogs tells you. You can see in vlogs, it's actually calling out the BCP and BCPing the data out. What we'll also see in the CAS is you'll also see, let's see if it's picked up. Hey, the link's degraded. So we'll go in there. In fact, hopefully, this environment wasn't set up too long ago. I'll still be able to show you. No. RCM is a relatively chatty log file because it fires every few minutes. So yeah, there's no. What you'll see in the RCM log file is you'll actually see the process of it BCPing out and then handing it over to scheduler and sender to do the normal site-to-site data replication. SEDO. Do you use SEDO? So, last piece of the session. Why do we need to control changes? So what happens in AD if two people create an object with the same DN? Last write wins, right? And the other object gets put in lost and found until someone decides to go and dig it out and potentially make it primary or whatever. Now, in AD, creating a user with the same DN is annoying, especially if you have different passwords. You could really annoy some users, but that's about it. Now, config-man, let's say you go and you create two objects. And those two objects, you decide to change where they're targeted. And you change one to be targeted to 100 clients. But someone else, somewhere else, says, yeah, I'm going to make it to 100,000 clients. Which one wins? Is it the one that's last? What if that one that's last is going out to the wrong set of machines? What if, the config change is incorrect? There are so many different permutations and impacts to what you're doing that the last write doesn't really make sense in that case. So, SEDO is the solution to that. So again, consider a scenario where two people are editing a task sequence. Again, who edits it, right? Even if they're at the CAS, they shouldn't necessarily be able to edit it if that change is happening on the primary. SEDO stands for Serialized Editing of Data Objects. SEDO is much cuter than saying Serialized Editing of Data Objects or Distributed Objects, depending on which revision of the SDK you look at. SEDO provides a way of enforcing single objects. It's a locking mechanism. Think of it like checking out a document in SharePoint. Locks should take less than 200 milliseconds. How can you break that? Well, if our SQL DBA, the evil one, our evil DBA, goes in there and he says, this SEDO queue looks really interesting. Let me turn that one off. Then he would break the locking mechanism for the entire hierarchy. Again, we really should do something about that DBA. We have a default timeout duration, though, which is 5 minutes. Only SEDO-enabled objects require users to obtain a lock before editing them. So there are certain objects that we say, you know what, there's no issue with making a change there. Those are fairly few and far between, as I'll show you in the next slide. And we support explicit and implicit lock handling. That's important for people writing SDK apps because you don't want to have to rewrite your apps to support SEDO, right? think about it, if you're editing stuff, you just want it to happen automatically. So the provider knows that, and it knows that for existing objects, what it will do is it will request a lock on your behalf. What are the SEDO-enabled objects? This is as of the beta SDK, so it is subject to change. But I haven't noticed any other ones, and that's pretty much everything that you would majorly modify. Okay. And again, things like global conditions and so on are more likely to have explicit requirements for SEDO locks because they're new. The older stuff, like the, I don't know, pick an update package, for example, is more likely to have an implicit SEDO lock because it's older and therefore would have been in the CM07 SDK. What does a SEDO lock look like? Well, here's our little admin there on the left-hand side. The admin attempts to open something from the provider. The provider requests a SEDO lock from the local site. That SEDO lock is then turned into a message that's dropped into the SQL Service broker SEDO queue. Not to be confused with Sudoku, which is different, very different. CAS forwards the SEDO lock on to the owning site if it doesn't own the object, right? So if the object was created at the primary site, then we pass it along. If it's a CAS object, then the CAS is able to distribute out the lock. In this case, it's another primary. That sticks it in its database, right? And we lock it out. In this case, it's now locked on the entire hierarchy. DRS then replicates that back. The provider then reads the lock and says, OK, this user now has a lock, and we're not going to allow anyone else to edit that. You can go ahead and edit it and make your changes, and then we'll take the lock off for you. In case you're wondering, so even in my initial testing of CM07, because I'm one person and I don't have a twin, my testing never actually showed SEDO. I never saw any locks because I was the only person testing. Yeah. So it only shows up if you have multiple people editing the same object. Yeah. So if you started testing it in your own lab and now you've started to play well with others and you've introduced it to other people, you may start noticing it. You will see the lock saying, this is locked by Contoso/Bob at site PR5. And you need to go have a chat with him about what you both are trying to do at the same time, because potentially there's some inter-communication skills that you need to work on. I don't know. Or change requests or some sort of process-related issue. SEDO lock properties. You'll see this if you look at the SMS object lock. Those are in the provider, so you'll be able to look in the provider and look at locks if you need to, and enumerate the locks and see what's going on in the environment using those locks. It's not a replacement for auditing, but it's in there anyway. And the important things in there are object version, which gives you a track back to the object in question, and then the assigned items are good for tracking down where it came from. Check the provider as our first stop to see if your SEDO lock itself failed. Check the RCM log for any obvious problems, right? If RCM isn't working, SEDO won't work. Hey, there's vlog again, but in this case, filter by component name like SEDO, and that will give you all the SEDO locks going on. Yep, check connectivity to the site that owns the object, right? Not just in general from the CAS. And yes, be on the lookout for evil DBA. So, a quick look at SEDO. I guess I should probably fix things. So let's go back in there and turn SQL back on. Okay, that's weird. There's a ghost in the machine. I wonder if RCM has actually done that on PR1. Anyway, something's fixed my stuff for me, which is good. Now, let's go in there and we'll go to, where am I at? Software library, software updates, deployment packages. I'll update my SCEP definitions package. And that now should have caused a lock in the environment. And if I haven't completely destroyed my environment with this demo, there you go. That's a SEDO lock. So you can hit there and keep hitting retry until it unlocks, or you can request to have a read-only copy and downgrade your rights. In this case, I'm actually using the same user, yeah, but just because I'm using the same user, because no one ever shares a username and password in an environment, right? No one would, no. So we still protect you from that scenario. Yeah, well, he's evil. You know, we can't trust him. And then you can see there we've got the SEDO queue, just to point out that there is actually a queue in SQL Service Broker for that. Primarily for the recording, those are the other sessions from PFE. Not much point to coming and visiting the booth because it's closed now. Fill out your evals. My value as a human being is defined by what you put on your evals, so be gentle, please. If you have any questions, you can come on up and we'll chat. Thank you for your time.